Molarity is a new concept for us, and it deals with aqueous solutions. So to this point, we've been talking about stoichiometry with solids, so that you're always going from like grams to moles or moles to moles or grams to grams in your conversions. But we have to know what to do when we're dealing with an aqueous solution. So an aqueous solution, if you recall, is just something that's been dissolved in water, like salt water. Salt water would just be, if we're talking about table salt, salt water would just be a solution of sodium chloride dissolved in water. So when you have sodium chloride aqueous, and you're going to use it in a reaction, you're not going to be given the number of grams of that solution, because if you think about what an aqueous solution is, if I have a beaker of salt water, it just looks like water. And most of the mass comes from water. So we have a bunch of H2O in here. The vast majority of the mass of what's in that beaker, even if it's aqueous NaCl, most of the mass is from water. And so if we're concerned with how many moles of sodium chloride we have to look at it a little bit differently. So you're always going to be given what's called a molarity. And molarity just means concentration. So the concentration of an aqueous solution is its molarity. So it's defined as the number of moles per 1 liter of a solution. And the symbol for molarity is capital M. So molarity is defined as moles divided by liters. So it's how many moles of something you have crammed into a given amount of space. So for example, if I have 0.45 molar solution of aqueous NaCl, that means I have 0.45 moles of NaCl dissolved in 1 liter. Now obviously if you have less than a liter, then you have less than 0.45 moles. If you have more than a liter, you have more than 0.45 moles. But the concentration of sodium chloride in that solution is 0.45 moles per liter. So let's look at an example of a question you might be asked. If we say, how many moles of zinc chloride are there in 2.5 liters of 1.5 molar zinc chloride? The first thing we have to understand is this molar means moles per liter. And anytime you see that capital M, that's what that means. So if I'm going to do a conversion here, I've got two numbers to start with, or two numbers that I'm given. I have the volume and I have the molarity. Now it's really important that we remember that the molarity, which is the 1.5, is a relationship number. It tells you the number of moles per liter, whereas the volume is an absolute measurement. It's just how much space does the solution take up. We always start our calculations with the volume rather than the molarity. The molarity will be used to help us along the way. So in this problem, if I'm asked for how many moles of zinc chloride, I'm going to start with the volume, 2.5 liters, and zinc chloride is ZnCl2. And just like any conversion problem, I want to cancel the unit that I start with. So liters of ZnCl2 is going to go on the bottom, and I'm asked for moles of ZnCl2, so that's going to go on the top. And this is a one-step problem, and the reason that I can do this in one step, unlike, let's say, going from grams of one thing to grams of something else, is first of all, I'm only dealing with one thing, zinc chloride. And second, I'm given the molarity, which by definition is the relationship between moles and liters. So if I have 1.5 molar zinc chloride, that means 1.5 moles per 1 liter, which is a relationship that I can put into the problem. So 1.5, the number for the molarity in the problem, goes next to moles, and a 1 goes next to liters. So it's simply 2.5 times 1.5 in this case. Okay, and if I do the math, I get 3.75 moles of zinc chloride, which would round to 2 sig figs based on my two starting numbers, so 3.8 moles of zinc chloride. Okay. All right, let's try another problem. This one says how many grams of sodium bromide are needed to make 500 milliliters of 0.800 molar NaBr, sodium bromide. So this is actually a problem that we're going to be doing in class where you actually make the solution yourself. And so if you're going to make the solution yourself, you need to know how many grams to use. So you're going to get a 500 milliliter piece of glassware that measures exactly 500 milliliters. And you need to know how many grams of this solid sodium bromide to dissolve in that 500 milliliters of water to give you this molarity. So the way we do this is we start, just like we did in the last one, we start with the volume, not the molarity. The molarity is important, but we're going to start with the volume. So we're going to go from 500 milliliters of NaBr, and that's our starting number. Now, we're going to be using molarity, which again, anytime you see molarity, you might want to just write off to the side, moles per liter. And since that's moles per liter, not milliliter, we need to convert to liters before we can go to moles. So I'm going to get rid of milliliters of NaBr and go to liters so that I can then go to moles. And 1 liter is equal to 1,000 milliliters. And then from liters of NaBr, so if you'll notice we did this up above, from liters, just like we did it with the ZnCl2, we can go to moles using the molarity from the problem. And in this case, the molarity is a little bit different. But I better put my unit label in first. The molarity is 0.800 molar NaBr. So that means that 1 liter is equal to 0.800 moles. And that allows me to cancel liters. The problem is asking me for grams though, so I have one more step to take, and this is a step that you guys should be familiar with, and that is to go from moles of NaBr to grams. Okay, so this comes from the periodic table. And the periodic table tells me that 1 mole of NaBr is 102.89 grams. And so then I'm ready to do my math. Okay, and this one gives me 41.16 grams of NaBr. Now I should round actually to 1 sig fig based on the wording of the problem, because there's only 1 sig fig in 500 milliliters. But if we're trying to make this solution, we really want to be as precise as we can. So if my balance can weigh out grams to the nearest hundredth, then I'm going to go ahead and weigh out 41.16 grams of NaBr. So anytime we're trying to figure out how many grams to use in a solution, we don't really need to round for sig figs. We want to be as precise as possible. Okay, so let's try one more problem. Now this one is actually some stoichiometry. We've got a reaction. So we've got zinc reacting with HCl. So that's going to give us a single replacement reaction. And it's going to give us zinc chloride plus hydrogen. And we're going to have to balance with a 2 in front of HCl. And I believe that's it. So the equation's balanced. So this time we're going to have to, let's plan this problem out. It's asking me for milliliters of the HCl. So in the end, I'm going to want to know milliliters of HCl. Okay. So you want to ask yourself, all right, what would I need to know to get to milliliters of HCl? So I could certainly get there from liters of HCl. And then what could I get to liters of HCl from? Well, based on what we've just been talking about, if I know the molarity is 0.600 moles per liter, that means I should be able to convert from moles of HCl to liters. And this problem is a little bit different because it's starting me with grams of zinc. So I've got grams of zinc over here, which I would then convert to moles of zinc before going to moles of HCl. So let me go ahead and set up the problem. So 32.5 grams of zinc. Grams of zinc on the bottom, and I'm just following my plan. I'm trying to go to moles of zinc. 1 mole of zinc weighs 65.38 grams from the periodic table. And then from moles of zinc, I can go to moles of HCl using the balanced equation, right? So in the balanced equation, I have 2 moles of HCl for every 1 mole of zinc. And then from moles of zinc, this is the new part. So everything to this point has been kind of old. We did this in class last time. But this is kind of a new part here. We can go, because it's an aqueous solution, we can go from moles to liters of HCl. And the equation tells us, the question tells us we have 0.600 molar HCl, which means 0.600 moles per 1 liter. So notice this time the molarity went on the bottom. In the previous 2 problems, the molarity went on top, but the difference is here I'm trying to cancel moles, so moles is on the bottom, and the molarity is the number of moles per 1 liter. So a 1 will always go next to liters, and then the molarity will go next to the number of moles, or the unit moles. All right, and then we have 2 more steps. So we're already at liters. Correct myself again, 1 more step. So we're at liters of HCl, and we're trying to get to milliliters, and so this should be pretty easy because there are 1,000 milliliters in 1 liter. Okay, and I did my calculation, and I get 1,657 milliliters of HCl, which is a big number, but milliliters are pretty small. And the 32 grams of zinc that we're reacting it with is fairly significant. And then to round for sig figs on this one, we will have 3 sig figs, so 1,660.